Okay, so today we're doing chapter 3.1, exploring quadratic relations. And you know from grade 9, linear relations, right? What kind of graph was that? Yeah, a line, a straight line. Quadratic relations draw something else. There's another kind of relationship here. Anyway, by the end of this class, I should be able to know the properties of quadratic relations. Here are some key terms. We're going to talk about the degree of the polynomial. We're going to talk about parabola, second differences, and you know about first differences, yes? Yeah. And then we're going to talk about symmetry, okay? Shh. So here, what I'm going to do here is I'm going to show you what the graph looks like. And here is a quadratic relation. Y equals ax squared plus bx plus c. I'm going to graph this, and we're going to talk about what it looks like, what the a does, what the b does, and what the c does. All right, so what I'm going to do is I'm going to go to Desmos. I'm going to graph this, and let's take a look at the graph and what it looks like. So let me go to Desmos here, and I'll type y equals ax squared. And then if you want to do squared here the fast way, instead of using these keys down here, you just do shift 6, right? The little caret. So so ax squared plus bx plus c. Okay, so I'm going to make all of these sliders. Yes, okay. So that's what a quadratic relation looks like. Is that okay? All right, so you notice what the quadratic relation looks like. It's a curve there. So let's write that in our notes and draw it or sketch it in our notes. So the quadratic relation looks somewhat like okay, so it looks something like this. If I were to describe this, what would I describe this as? A curve? Yeah. What else? A U? Yeah, okay. So it's a U. Now, if you look at mine, maybe it doesn't look very nice here. But if we looked at the one in Desmos, what can you say about the curve about the middle here? It's symmetrical, right? So down the middle, okay, if I were to put a mirror, then it will mirror on the other side. Okay, so this is a symmetrical U-shaped curve. And the name of this curve here, we call it a parabola. Okay, so when I talk about a quadratic relation and the graph, I will call it a parabola. Okay. Now, notice how I drew this dotted line. What would I call that dotted line? Does anyone know? The line of symmetry, or I'm going to call it the axis of symmetry, okay? So the axis of symmetry. I'm going to just abbreviate it as AOS, okay? So axis of symmetry. Is that okay? Now, if we remember from grade 9, like we had the y equals mx plus b form, right? And then we had the like ax plus by and so on. There are different forms of quadratic relations. This one here we just call standard form. Okay, so this is a quadratic relation in standard form. Okay, so this is the quadratic relation in standard form. If I change the value of a, how will the graph change? So I'm going to do number 2 here. What does the value of a do to the graph? Let me go back to Desmos and let me change the value of a and see what happens. Are you watching carefully? Okay, so watch here. So a equals 1 right now, and I'm going to Okay, so A is getting bigger. A is about 4 now. What is it doing? Did you see what it did? Yeah, it made it like skinnier or thinner, right? Yeah. So, and then let me go over here. Okay. Well, uh-oh. And oh, okay. So what happened? So when A was positive, the parabola opened what? Up. However, when it became what? Negative, it actually opened down. And when it was what? 0, it was no longer a what? A parabola. So let's think about that. Why is it if A equals 0, it's not a parabola? Yes? That's right. Very good. So if A equals 0, okay, A is 0, then it's 0 times x squared, which becomes 0. So then y is just what? Y equals bx plus c, which actually is just a linear relation. Okay, so let's write that down in our notes. Okay. So in standard form, we cannot have A equals 0 here. A cannot equal 0 because if A equals 0, then what happens is, okay, it becomes a linear relation. So let's show that here. So remember, this is like a good communication question, right? Why can't A be 0? What's the restriction on A? What's the restriction on A? A cannot be 0, okay? So because if we do that, if A equals 0, y equals what? 0 x squared plus bx plus c. And then we get, that's gone, so we just get bx plus c, which now is what? Linear. Okay? It's no longer quadratic. So let's talk about the other thing that we saw with A. So if A is greater than 0, what happened? If A was greater than 0, what happened to the parabola? Curves which way? Up, right? So we say that it opens up. Okay, so this one was A is a positive number. So if A is positive, A is greater than 0, A is positive, then what happens with the curve? It opens what? Opens up. Okay, so opens up. Okay, now if A is negative, or A is what? Less than 0. So that means if A is less than 0, it means that A is going to be what? Is negative. What happens to my curve? It opens like this, yes? So opens down. We say that this one opens down. Okay? Easy way to remember this. Look. A is what? Positive. If you're positive, you are happy. Okay. A is negative. If you're negative, you are what? You're very sad. Okay, very good. You understand? If you don't remember this next time, you're gonna, I don't know. Okay, so that's how A affects the graph. Let's go and see what B does to the graph. So write down number 3 here. What does the value of B do to the graph? Okay, so let's see what it does if I change B in my graph. So let me change A back to 1 here. Let me change B. Just watch carefully. It's kind of hard to tell though, but it's just shifting the just shifting the parabola, right? No, it doesn't make a circle, no. But, okay, yes. Okay, all right. So okay, shh. All I'm gonna write for that is just moving the axis of symmetry. That's all I'm gonna write for now. We'll learn later how B exactly affects the parabola, but I'm gonna just say here for now B changes the position of the axis of symmetry. Okay, so that's all I'm gonna say for B right now. All right, let's take a look at what C does to the graph. So let me go back to Desmond's here. Let me change this back to 1. And right now, C is 1. Are you watching? C equals 1. Let's see, C equals 2. Okay, so C equals 2. C equals 3. Let me change this a little bit so you can see it more clearly. C equals 4. C equals 5. 5. You see it? Where is it?
It's up. It's at 5.
It's where? Right there. Yeah, so C is the y-intercept. So remember in your linear relation, B was your y-intercept. In this case, C is your y-intercept. And let's take a look at why it is. C is the y-intercept. Okay. Meaning the y-intercept, what's special about the y-intercept? The value of what? X equals 0. Okay, so think about it. If x equals 0 and y equals ax squared plus bx plus c, so if x equals 0, y equals what? Yeah, y equals c. Okay, so look. Y equals a 0 squared plus b times 0, okay, plus c. Well, that's crossed that one, and so what happens here? Y equals to c. When what? When x equals 0. Okay, so y equals c when x equals 0. So that makes it the y-intercept. Got it? All right. Okay, so what if I look at a graph, I should be able to say whether that's quadratic or not. And like I said before, a quadratic draws a what? Symmetrical, okay? Symmetrical U-shaped curve. So if it's a parabola like this, then it could be a what? A quadratic relation, right? It has to be. So the graph has to be a parabola, which is a symmetrical U-shaped curve like that. Okay? All right. So this is quadratic. Okay? A not quadratic might be like right? So this is not symmetrical. Like, where is this axis of symmetry? Eh? Not symmetrical, right? Therefore, it's what? Not quadratic. Okay? And if it's a straight line, it's going to be a what? Linear, okay? Is that okay? So from the graph, it's pretty easy. If I give you a graph on the test and I say, is this quadratic? All you have to say, oh yeah, it's a parabola, so it's quadratic. Is that good? Or this is not symmetrical, therefore it's not quadratic. Simple question, yes? Okay. The axis of symmetry? Yeah, we'll learn how to do that uh, as we go through chapter 3, 4, 5, 6. Okay? All right, the equation. When we look at the equation, how can we tell it's quadratic? So, yeah, and let me just say that the degree of the equation has to be 2. Now, I did talk about this in grade 9. Do you remember what it meant to be the degree? Yeah, yeah, the exponent, right? So, the highest exponent. Shh. Okay, so the highest exponent on the x or the independent variable. So, I mean, you could have different letters, but usually talk about the x. So if x is squared, then that's what? Quadratic, right? So let me give you some examples of quadratics. Yeah. The highest. Okay, so the highest exponent should be 2. So independent variable. Independent variable. Y equals. So what are some examples of quadratic? Y equals what? 2? 2x squared? Yes, okay. Yeah. Another example. Y equals x squared, right? Yeah. Y equals negative 3x. That's what? That's what? Linear. But then if I add like x squared, now it becomes what? Quadratic. So notice here that the highest exponent, the exponent on this is what? 1. The highest one on the exponent on the x is what? 2. So that must be quadratic. Is that okay? Okay. Yes? So I'm just writing examples of quadratics right now. Is this quadratic? Are you sure? Is actually what? It is quadratic. Okay, and why is it quadratic? Watch. X times x, that. X times x gives you what? X squared. Uh-oh. Now we have x squared, so it must be quadratic. So plus 2x. Okay, so this is actually quadratic. It's a little bit tricky because, it doesn't look like quadratic because there's no exponent of 2, but if you actually expand it out, you would get x squared. Okay, let's write non-examples. So non-examples of quadratics. Okay, so basically not quadratic. Y equals what? X. Y equals what? X cubed. Right? Y equals x squared plus x cubed. You understand? This is not quadratic because the highest one is what? 3. So it means it's not quadratic, it's actually cubic. All right, so if you look at the equation, it has to have a degree of 2. If it doesn't, then it's not quadratic. Let's take a look at the table of values. Okay, if from a table of values, how can you tell if something is quadratic or not? And so let me give you a table of values. So x, y, put 0, 1, 2, 3, 4, -2, -1, 2, 7, 14. Okay. Shh. In grade 9, I gave you a table of values and I asked you, is this linear? And to show that it was linear, what did you do? You found the first differences. Now, when you find the first differences, you're looking for, how much is it jumping up or down from one point to another point. So let's do that. So I'm going to do the first differences here. If you do the first differences, okay, what do? Remember the what? The bottom number subtract the top number. So what is it? -1 minus -2. That gives you what? 1. And you keep doing that all the way down. What do you get? 2 minus -1, which is 3. Okay. You keep doing that. 7 minus 2, which is 5. Okay, and then this one, 14 minus 7, which is 7. Okay, look. From point to point, every time I move over 1 on the x, is it going up or down by the same amount on the y? No, right? The first time it went up 1, and then the second time it went up 3, and then up 5. So could I draw a straight line through those points? No. So these are not the same, therefore this is not linear. Okay, not the same. Not same, therefore not linear. All right, since the first differences weren't the same, that means it's not linear, so I should check the second differences. When I check the second differences, how do you think I do it? Exactly the same. I take these numbers and I subtract them. 2. 5 minus 3 is 2. 7 minus 5 is 2. Amazing! They're all the same. So if these all become the same, okay, they're all the same, therefore this must be what? Quadratic. Okay, therefore this is quadratic. So if the second difference is positive, the parabola will open up. Same thing, if the second differences are negative, then the parabola will open down. Okay, and that's about it for today. You can start your homework.